Week 2, lesson 6. All right, so you already all know that a line is defined by 2 points, right? Not that big of a deal. A plane, however, is defined by 3. That's the minimum number of points it takes to define a plane. So I'd like you to take a look at this picture over here to the right, and I'm going to talk you through sort of the derivation here of the vector equation of a plane. All right, so this is saying there's a vector from A to P, right? That vector is some linear combination of vector AB and AC. Those two Greek letters, by the way, this is lambda, this is mu. All right, so what that's saying is if vector AB was extended by some scalar, and if vector AC was also extended by some scalar, that you would end up with vector AP. All right, so then for this particular line, they got P minus A by doing head minus tail. Head minus tail, head minus tail. All right, and then for the next line, they moved this A to the other side. Okay, that's all they did. They moved A to the other side. And then to try to sort of clean this up and make it not quite so, involved, they said, well, let's just rename vector AB as vector U, and we'll rename vector AC as V. So substituting those back in, you get this, which, if you look in the blue box down below, is what you're seeing here. It's a lot like the vector equation of a line. Okay, vector equation of a line, you had a starting point and a direction. This is really similar. You have a starting point here, and then you have 2 directions, which kind of makes sense because a line is only in 2 dimensions, but a plane is in 3. All right, so then again, if you look down below, you can see the Cartesian form of a plane. It looks a whole lot like standard form, right? When you're thinking about standard form of most things. But anyway, you have these available to you. Hopefully you printed out these notes. I have one example to do with you. Here we go. So it says that we have a plane and it's passing through these 3 points. We're gonna find the vector equation of the plane. Now, in order to do that, I need a starting point. So again, you can choose any one of those. Okay, I don't really care whether you pick A, B, or C. I think I picked A. And then there's going to be lambda times one direction, and then there will be mu times another direction. Now, I've given you points, not vectors. So we need to find a couple vectors so we have some directions. So I'm going to find vector AC along with vector AB. All right, AC, if I do head minus tail, is 2, -3, -1. And vector AB, again, head minus tail, 1, -2, -2. And I just have to put those into these 2 locations that are describing a direction. 2, -3, -1, and 1, -2, -2. Okay, continuing, right, with the same exact problem. Parametric equations are just where you sort of split this up. There will be 3 of them here. There'll be sort of like this top line, and then there'll be the middle line, and lastly there'll be the bottom line, right? An equation for x, an equation for y, and an equation for z. X will equal 1 plus 2 lambda plus mu. Y will equal 2 minus 3 lambda minus 2 mu, and z will equal 1 minus lambda minus 2 mu. All right, and then the very last example, and this one's going to take a little bit more time. When it says to find the Cartesian equation of the plane, in English, what that means is I need to go right up above to these parametric forms and eliminate the parameters. Okay, meaning I need to find a way to get rid of both mu and lambda. All right, so I'm going to take the first equation, the one in red, and the blue equation, and I'm going to eliminate mu by multiplying the first equation by 2. All right, so I get 2x is equal to 2 plus 4 lambda plus 2 mu. And the second equation I'm just bringing over, right? I'm not changing it at all. But the reason I'm doing this is so that these cancel out. So if I add these straight up and down, I have 2x plus y equal to 4 plus lambda. Okay, I'm going to let that sit there for a second. Okay, now I'm going to go back to my originals up top, the red, the blue, and the green, and I'm going to find a way to get rid of mu again, which means I think I just have to multiply the second one by -1. So let's change the second one to negative y equal to -2 plus 3 lambda plus 2 mu. And the green one I'm just going to bring over. Z equals 1 minus lambda minus 2 mu. Right? Adding those straight up and down, I end up with z minus y equals -1 plus 2 lambda. And now I need to eliminate lambda. So I think what I'm going to do is multiply this one by -2. So negative 4x, negative 2y equals -8 minus 2 lambda. And this one I'm just going to bring over. Z minus y equals -1 plus 2 lambda. Scoot this up a little. Sorry about that. When I add these up, I have, let's see, negative 4x minus 3y plus z. Over here, the lambdas are gone. I have -9. But personally, I kind of like Cartesian form or standard form to start with a positive. So I'm going to switch all the signs. 4x plus 3y minus z equals 9. That's the final answer there.